Hi folks, welcome back to Physics with Captain Rod. I am making this video here to, gotta move my speaker. Give me a second. Okay, making this video here to talk about your final exam. So I'm gonna base your final on this one, so hopefully you'll look through these problems. So let's talk about this. Let's see, a car's traveling at 40 miles per hour. A driver sees a deer and hits the brakes. It takes 5 seconds for the car to stop. Draw a velocity versus time graph for during the 5-second time frame. All right, so a velocity graph, it's going to look something like this. There we go. All right, so again, velocity against time. Now remember, velocity is talking about how fast something's going and in what direction. Now, before we actually talk about the graph, you'll notice it says something about find the acceleration in feet per second squared or feet per second. So probably the first thing you want to do is take this 40 mile per hour and you're going to want to convert it to feet per second, right? And there's 5,280 feet in 1 mile. Okay. And then at t equals 0, ask yourself, how fast is the car going? And then put that point somewhere on this graph. I don't want to do that for you. That's your problem, your problem to work on. And then 5 seconds later, the car has stopped. So there's another point on the graph. Right? Put that point on the graph and then connect the dots. Now, remember, acceleration is change in velocity over change in time, right? And you got to understand how that relates to that graph. And then the distance traveled, right, is going to equal the area. So remember that the distance traveled when you got a velocity graph is the area under the curve. So anyway, that's how you're supposed to solve that. Let's move on and talk about number 2. Okay, number 2, an arrow is fired straight up in the air. What is the initial speed of the arrow if it reaches a maximum height of 400 meters? So start by drawing a picture. That's going to look something like this. All right, here's the arrow. And we would call this position 1. And the arrow has a speed, but we just don't know it yet. So we'll call that like V or maybe V1. It doesn't matter which. And then draw a picture of the arrow up here. Here's position 2. And it's important to realize at the highest point, the speed of the arrow is approximately 0. So I'll put approximately 0, because it might have a little horizontal motion, but not much at all. Okay, then write out the work energy theorem. Remember, PE1 plus KE1, etc., etc., etc. And when you work this problem out, you should have no PE1 term. Your KE1 will be 1/2 mv squared. The PE2 is an MGH term, right? This is some height, and the KE2 is approximately 0. And if you're familiar with seeing a work term in the work energy theorem, there's no work in this problem. There's no work done. Okay, number 3, let's see. 1,500 kilogram, got kilogram twice. 1,500 kilogram elevators lifted 20 meters by an electric motor. That is 7 horsepower. Find the change in potential energy of the elevator. All right, so potential energy is MGH. Right, and there's basically an M given, and hopefully we know that what gravitational acceleration is, and there's a 20-meter height given. Okay, part B, calculate the power in watts. So power is change in energy over change in time, because power is the rate that energy is transferred. And this is equal to the change in energy. Oh, okay. The power, as far as what we're going to put here, right, it's a 7 horsepower motor, but that's not the correct units. Horsepower is an English unit. This needs to go to watts first, and there's 746 watts in 1 horsepower. So calculate the horsepower in watts, and then that number will go here. And then the change in energy you're going to get from here. Oh. I'm sorry. I think so I did mess something up here. I'm going to just fix this. What I just described is how you do part C. For part B, where it says what is the power in watts, just take the 7 horsepower and then use this as a conversion factor to calculate it in watts. And then everything I said about the first part B is going to be good down here. Sorry about that. Okay, number 4, a rock is dropped off a bridge. So maybe, here's our bridge, and maybe here's the water below. And the rock starts here at the bridge, right, and accelerates down. Hits the water 5 seconds later. So this is just a question about acceleration. And remember that acceleration is change in velocity over change in time. And for gravitational acceleration, you're going to use 9.8 meter per second per second. And then the delta t is given in the problem, so it probably won't be much of an issue, hopefully. 5, estimate how long it will take to drive 200 miles, assuming a speed of 65 miles per hour. So speed, or let me say your velocity, is distance over time. Take the 65 mile per hour. Actually, I guess it's just fine. You can put that value in here, and then the 200 miles can go here, and you'll solve for t. You'll get some number. And once you have that time, just convert it to minutes, because it says how many minutes to do the following. Okay, 6, the cost to run a 1200 watt dryer for 10 minutes, assuming 12 cents a kilowatt hour. This is kind of an old exam here. I'm going to actually have you use 20 cents per kilowatt hour. And I will post some answers to these later, maybe not today, but very, very soon. And I'm going to use 20 cents a kilowatt hour because that's what my last electrical bill was when I do that. And so when you're billed with electricity, you're billed by what's called the kilowatt hour. And 1200 watts is 1.2 kilowatt. And then figure out how many hours that is. Right? So get this is going to be a number in hours. And then you're going to multiply 1.2 kilowatts times this number in hours, and you're going to get a value, a number in kilowatt hour. And then you're just going to take that and multiply by the 20 cents per kilowatt hour. And that should get you by that. Seven, I'm not going to discuss here. This is just for you to decide. This is just a knowledge thing, all right? Which of these is the shortest wavelength? And keep in mind, shortest wavelength would mean highest energy. Highest frequency. That's basically the same type of question. Okay, 9, a light bulb with 5 ohms of resistance is ran off a 120 volt AC voltage source. Draw a simple circuit diagram for that. So I'll go ahead and draw this for you. Okay. This sawtooth looking thing is what we use for resistance, and then this circle with a squiggly is what we use for voltage. So this is the 120 volts, and this is the resistance. And that's what the circuit diagram looks like. And then when it says what average current, that's just an Ohm's law question. Voltage is equal to current times resistance. And you're going to use the 120 for the voltage and the 5 ohms for the resistance. Now a little bit about AC circuits. Remember that AC is a varying voltage that looks like this, like voltage against time. And the peak, all right, is actually 170 volts. You don't use the peak for calculations, though. You use an average voltage, or what's called the RMS voltage. In this case, this would be the 120. So anyway, the 120 goes here. The reason I point this out is if it said 170 volt peak, you still use the 120. Let's see. A, let's see, what is the direction of the electric field halfway between these charged particles? So that's talking about here. And the electric field direction is based on the force direction on a small positive test charge. So just ask yourself, if I put a proton here, a positive charge, what will the force direction be, right or left? So I guess I would answer part B first, and that will tell you the answer to part A. No calculations required. That's just a conceptual question. Number 11 is about transformers. So remember, here's kind of like the little schematic of how transformers work. They have an input voltage and an output voltage. And you have a certain number of windings on the left, like N1 here, and a number of windings on the right, N2. And your output voltage is equal to N2 over N1 times the input voltage. So this 200 turns on the primary side is talking about this. 40 turns on the output side is talking about this. And then 120 volts is the input, so that's talking about this. So that's how you calculate the voltage out. To get the current out, right? Remember, power is current times voltage. So on the input side, you've got the current in times the voltage in. And on the output side, you've got the current out times the voltage out. And the 100% efficiency basically means we're going to call these equal. And the current on the input side right here is the 5 amps. And then take the two voltages, the 120 volts and the voltage that you calculated here, the output voltage, and then you can find the current. Okay, number 12. The following graph describes the motion of a particle. So this is a position graph. And the velocity, remember, is change in x over change in t. And remember, this is a slope. See how this looks like change in y over change in x, or rise over run? So velocity is the slope of this graph. So when it says, what is the velocity of the particle at 3 seconds? So at 3 seconds, we're here on the graph. And what you need is the slope of this line. Just pick 2 points on the graph. I would use this one and this one. And then calculate the slope. Part B, what is the velocity at 6 seconds? So 6 seconds, we're here on the graph, right? Same thing goes. Pick 2 points on the line, maybe this one and this one, and calculate the slope of that line to get the velocity. Okay, now this one's a velocity graph. So this graph is telling us whether the particle's moving or not based on the reading. And a lot of these are conceptual questions, and I don't want to give the answers away to all of these. But to answer this one, when is the particle at rest? Well, you're looking for a point on the graph where the velocity is 0. Part B, where it says, what is the acceleration at 2 seconds? So acceleration is change in velocity over change in time. And it's important to realize that is a slope. It's the slope of a velocity versus time graph, which is what we have here. And at 2 seconds on the graph, we are here. So when it says, what is the acceleration of the particle? It's asking for the slope in that region. Okay, so these are all just unit conversions. So joules to EV, you're going to need the conversion factor. There's 1.6 times 10 to the minus 19th joules in 1 electron volt. Right? Miles to feet, there's 5,280 feet in 1 mile. That's the conversion factor you're going to need. Oops. Horsepower to watts, there's 746 watts in 1 horsepower. I don't expect you to memorize conversion factors. I would put all of these that you're going to these are all conversion factors you definitely want to have in your notes. You can have them when you take that exam. And if there's other conversion factors that you'll need, I'll supply them. Okay, a hydrogen atom. Calculate the energy of a photon produced when an electron drops from n equals 1 to n equals 3. So I don't expect you to memorize these equations, but hopefully you remember we talked, at least video-wise, about the hydrogen atom and Bohr theory. And the energy of an electron in a hydrogen atom is equal to minus 13.6 electron volts over n squared. So put in n equals 3, get a number, and it's going to be negative, and that's fine. Put in n equals 1 and get a number. All right, and that's going to give you another negative value. And then take the difference between them. Take the energy you get for the 1 and subtract the energy you get from the 3. And I believe you should end up with a positive value if that comes out. Right. Let's see, 14. A photon with 10 EVs of energy is absorbed by an electron in the n equals 2 shell. The electron leaves with how much kinetic energy in EVs? All right, so let's say here's our nucleus, right? And here's our first shell, and then we have the second shell. And the energy in the second shell is minus 13.6 EVs over n squared. Put in the n equals 2 to get a number. This is going to be some negative number. Trying to think about what the rest of this means here. The electron leaves it. Oh, okay, I got it now. All right. So now, when you add this energy to this, you're going to get a positive number. And it turns out that this is enough energy to get that electron to leave, to ionize the atom. And again, when you take this and add it to this, the positive number that's left over is going to equal the kinetic energy that the electron leaves with. Okay, 15. What is the wavelength of a photon with a frequency of 1500 hertz? So for all wave phenomenon, velocity is equal to frequency times wavelength. I know I hate all the Greek letters in physics. This is the Greek letter lambda, usually used to represent wavelength. And the frequency is the 1500 hertz, or 1500 per second. And this is a photon. And the velocity of all photons is the speed of light, which we call c, 3 times 10 to the 8th meter per second. And that number will go here. And then you will solve for f. So anyway, there's how to do these problems in a nutshell. I'm going to work on some solutions to this, try to get them posted later today for you. And please feel free to contact me if you're, email or text if you're having trouble with these and can't get the answers to work out or something like that. When you get ready for your final exam, I'm going to base your final exam on this exam, right? So work this out, practice as best you can, show all work where appropriate. I hope that this video helps. Have a great day.